Assalamualaikum everyone. Welcome to Mathematics with Shahab Yaqub. So now the focus in this class is that of differentiation, but much more than differentiation. I'm interested in integration. So now let's pick some past papers, and I'm picking them up from this particular year, that is 2023. And let me go through different questions. Now let's look at this one, which is about trigonometry. No, trigonometry we have done a lot. Let's focus on this. So let's first look at the question. So we are focusing on question number 5. And it's about the equation of a curve as x square y minus ay square is equals to 4a cube, where a is a non-zero constant. What does this statement means? When a is a non-zero constant, that means the value of a will come out to be 0, but you should reject it. And when do we get something equals to 0? When we take common. So common, that always has superiority over division. The first part is show that dy by dx is this much. And then the second part, that's also there. Let's focus on the first one. So this is a question of implicit differentiation. You would have realized it by now. Let's look at the solution. It says differentiate both sides with respect to x. This is a constant, derivative is 0. X square y, that is x square into derivative of y, which is 1 dy by dx. Minus as it is over here, that is for later. First of all, over here, y into derivative of x square is 2x. So this thing is done in green. And then over here, this minus sign is there. So let me highlight this minus sign. This minus sign is this minus. And then this thing, that is ay square. That is a is a constant. And this is y square is differentiated. That is 2. And this is y. And this is dy by dx. So this is not product rule because a is a constant. And then eventually we make dy by dx the subject of the equation. Since they want it in this format, so take negative common from the top, take negative common from the bottom, remove it, the signs change, and this is your answer. The next part. Now it says, hence find the x and y coordinates. When it says coordinates, that means both x and y. Both x and y. Of the points, that means there will be more than one point where the tangent to the curve is parallel to y-axis. When the tangent is parallel to y-axis, gradient is undefined. What makes a gradient undefined? When the denominator is 0. So this was the denominator. We make it equal to 0. We solve it simultaneously with the equation of the curve. So make x squared the subject. Wherever there is x squared, just replace it. Y square is 4a square, y is plus 2a, y is negative 2a. When we plug this thing over here, we get x is plus minus 2a. We cannot take square root of a negative number. We discard it. And then over here, when x is 2a, y is 2a. When x is negative 2a, y is 2a. So these are the two coordinates. Now, what was the purpose of saying that a is a non-zero constant? As such, we did not come across this thing. But if a is equals to 0, this thing will become 0. And x square y is basically y is equals to x square. So you won't be getting this. That is the logic for this particular question. Okay, now let's move on. This is differential equation, which we started recently. Now, I think this is a binomial with integration. A very nice question. Let me add a page over here. Let me add a page over here. Let me do some adjustment like this. And let me just adjust it something like this. Okay. So now let's read the question first. Let me highlight it. This is question number 8. It says fx is this. Express fx in partial fraction. That is for 5 marks. Next part, hence find the exact value of this integral. Give your answer in this form. That is the exact form. There should be a constant term. There should be something with ln. Where a, b, c are integers, that's another 5 marks. So 10 marks altogether. So now, first of all, realize this. What kind of fraction is this? The highest power of the numerator is 2. The highest power of the denominator after multiplication is 3. Yes, it's a proper algebraic fraction. The next thing that we need to consider is this, which case of partial fraction is this? So this is case number 3 according to our working. Of course, the examiner doesn't know how we have numbered it, so we should write it down. This is linear repeated case, because this is x plus 2 whole square. So technically, it would be a over 2x plus 1, b over x plus 2, c over x plus 2 whole square. That is what we will be getting. So once you have realized this thing, then also you should realize how each term will be integrated. This will give us ln. This will give us ln. This will be an application of chain rule of integration. So basically, first make the strategy. First strategize. And once you have strategized, then proceed. There is no hurry as such. So now over here, let's get started. The same thing I've written over here. So now these papers were done when I was solving the yearly past paper session online. So that's when I have done these questions. I have worked in the same similar manner. Partial fraction plus integration. Even I have labeled this. Now take the LCM. We get the value of A as 1, C as 3, and B as 2. So this is what you are getting. That is pretty basic. Now, this concept of integration will be used. That is the chain rule. So now let's look at the simplification. Focus on the coefficient of x. Everywhere, focus on the coefficient of x. This is 1 over 2. This constant 1 is there. So there was no need of writing it. Even if I want to, I can write it. This is 1 over 2 ln 2x plus 1. This negative 2 as it is. 1 over 1. Even if it's a 1, make a habit of writing it down. Ln x plus 2. This 3 remains as it is. This was taken up. Unless and until you take it up, you cannot integrate. Increase the power by 1, divide by the new power, divide by the coefficient of x. Now, the next stage is simplifying. This remains as it is. This remains as it is. Negative 2 plus 1 is power 1 in the denominator. Once you have reached this stage, then plug in the values. And these kind of simplification we have done a lot. So if you want to take a picture, I think it's a good idea that you take a picture. And also note it down, which paper are we talking about? May, June 2023, variant 31. So let me just stop it for a second, take a picture. So this thing is done. And then over here, this thing is done. It's of the form a plus b ln c. The value of a is 1. The value of b is negative 1. The value of c is 3. And a, b, c are integers. So all good, all clear. Now, the first part, well, it's related with numerical solutions. So let's skip it for right now. Now, let me move to the next one. This is May, June 2023, variant 32. I'm moving to this thing. Implicit again. Differential. The same kind of question. Now, this is a good one. Very nice question. Let me add a page. Let me add a page. Let me do the adjustment. Okay, people, let's have a look. First, read through the question. It says the diagram shows the curve y is equals to x plus 5 square root 3 minus 2x and its maximum point M. So by now you have realized, since this region is shaded, one part would be about integration, the other part would be about differentiation. Find the exact coordinates of M and use the substitution, find by integration. No other way, find by integration the area of the shaded region bounded by the curve, the x-axis. Give your answer in this form where a is a rational number. So again, 5 marks for this one, 5 marks for this one. This is about differentiation. This is about integration. So now let's look at the first part. The first thing what I did is that basically it's for the second part is that I'm looking for these two x-intercept. Y is equals to 0, x plus 5 is equals to 0, x is negative 5, square root equals to 0, therefore x is 3 over 2. That is the step. That will be used later. This is an application of product rule, u prime, v prime, just like what we did in class. And then uv prime, vu prime. No need of simplifying because any which way we are making it equal to 0. Understand what the question is asking. Don't just get started right away without thinking. They're not asking for the expression. They're asking for the exact coordinates. They're asking for this. So there was no need of simplification. Negative, negative cancel. Multiply it out. Root a is a. Root 3 minus 2x, 3 minus 2x is 3 minus 2x. X comes out to be negative 2/3. It makes sense. It's on this side. Yes, the x coordinate is negative. When x is negative, plug it in, rationalize, simplify, you get this answer. And it's in the third form. Does it say exact? Yes, it says so. So fractions are exact, thirds are exact. In terms of pi, in terms of e, in terms of ln, this is all exact. Now use the substitution, find by integration the area of the shaded region. Now let me pause the recording for a second. Let me share these two images with you so that you can try out the second part. It's worthwhile. Take 6 minutes, 7 minutes, try it out. Let me pause the recording first. So now people, let's look at the solution for the second part. Let's start from here. U is 3 minus 2x, du by dx is negative 2. So now we have, this is the equation of the curve on the inside. And I'm replacing dx with negative half du. That's the first thing. Root of 3 minus 2x is basically root of u. That is the second thing. X plus 5. First make x the subject. U is 3 minus 2x. I'm making x the subject. That is 3 minus u over 2. X plus 5 is 3 minus u over 2 plus 5. And it simplifies to 13 minus u over 2. It simplifies to 13 minus u over 2. Also, the limits are changed. So this 2 from here, this 2 from here, take it outside. That is 1/4. Get rid of this negative sign. 0 and 13 will change places. This is root u. This is 13 minus u. This is power half. This is power 1. This is power 0. So this is 13 u raised to power of half minus u raised to power of 3 over 2. So I hope up till here, it's all good. You go step by step. You change dx. You change the root. You make x the subject. You add 5, simplify. You change the limits. That's right over here. That is the limits change thing. and place limits where they belong. That's what I have taught you. And change everything in X to everything in U. That is what we have done. The minus sign is taken care of. These two change places. This 4 goes on the outside. Now the integration starts, which is very basic, which is P1 integration. Increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power. Division by 3 over 2 is multiplication by 2/3. 2 into 13 becomes 26 over 3. Multiplication by 2/5. Now, what else have I done? This is u raised to power of 3 over 2. That is u power 1 and u power half. So this is u root u. And this one is u square root u. So I have taken root u common out. Okay. So let me write over here. This is u root u. This is u square root u. So now this root u is taken common out. This u is left. This u square is left. The constants, I haven't touched them. Now let me plug in the value. So 13 is plugged in over here. 13 square is over here. This root 13 is over there. And the rest. And then later on, I took common. So someone can take common initially from u and u square. I could have taken common out. Or someone can plug in the value and then take common. And at the very end, the answer is coming out in this strange form. Root 13, 15, 169. That is the answer. Let's move on to next paper. Now let me choose something different. This looks nice. Okay, let me add a page first. This is the first part. And then the second part, this is integration by parts. So I think this is, hold for a second. There is this thing. Okay, let me just double check. This is 7 part A. This is 7 part B, and then there is 8. Okay, now let's look at the question. Let me just double check one thing about the recording, because some people would be needing it. Now it says, use the substitution, show that this thing becomes this. So it's a nice question. You have to change everything. Again, it's substitution, but now it's becoming something like this. And this thing will be solved using integration by parts. That is the second part. 4 mark, 4 mark. So 8 marks. Now, first of all, u is cos x. Just focus on this side. U is cos x. Du is negative sine x dx. If I have sine x dx, actually this is sine 2x. Right now I have sine x dx, that is negative du. Limits 0 and pi. Limits 0 and pi. When x is 0, u is cos of 0, which is 1. When x is pi, u is cos of pi, which is negative 1. So lower limit is 1, upper limit is negative 1. Lower limit is 1, upper limit is negative 1, and that will change later on. Sine 2x is written as 2 sine x cos x. So first of all, you have to break it up. Nothing special. So this sine x dx, that is negative du. E raised to power of 2 cos x, e raised to power of 2u. Cos x is u. 2 is 2. This negative changes the position of these two. So now a lower value is downstairs, bigger value is upstairs. So that was 4 marks for this. So this, for the first time in this recent paper, you have seen that we have done a substitution and it becomes integration by part. So now this is one thing that I hate. That is that we use u and dv. So they shouldn't use this symbol. They should have used something else, any which way. U is 2u. This is algebra. This is exponential. So algebra exponential integration by parts, u is 2u. du is 2 2 du. dv is dv is e raised to power of tu 2u du. I think this is du. I think it's written twice. Let me just write it properly. Okay. So therefore, v is this thing. You integrate and you get this thing. uv minus integral v du. So that is uv minus integral v du. That is basic integration. Take common, plug in the limits, simplify, and that was a very straightforward question. Differential equation, we don't have to do. This is binomial, this is complex number. Let me move to the next paper. Now, another integration by parts question. The diagram shows the curve y is equals to x e raised to power of negative 1/4 x squared for x is greater than or equal to 0 and its maximum point m. Find the exact coordinates of m, that is product rule. U prime, v prime. And look at the power. You're getting an x squared, but differentiation has no concerns. dy by dx is this thing, take common, make it equal to 0. E raised to any power can never be 0, no solution. And from here, x is coming out to be positive root 2, negative root 2. Why is the positive one correct? Because you can see that x is positive. When x is positive, plug in the value over here. You get the y value. You need the coordinates. That means both x and y coordinates. Use the substitution. X is root u, or otherwise, I think we will just use the substitution. Find integration. Find by integration the exact area between 0 and 3. So this is 0. This is 3. You're looking for this area. X is root u, just like what we have done in class. X is root u, or u is x squared. Du is 2x dx. If you are just changing dx and you also have x, so x dx is half du. X dx is half du. U is x squared. So e raised to power of negative x squared over 4 is basically e raised to power of u over 4, negative. Limits are changed. And then it's a simple integration. So this thing in terms of x becomes in terms of u. Very simple integration, exponential. Plug in the limits, and then you get this answer. This is binomial, vectors. This one is good. I would like you people to try it out first. I think it's just a one-page question. Yes, it's a one-page question. So now think about it yourself, how it needs to be tried out. So sending this over to you people. And let me pause the recording. It's also visible on the screen. Let me first forward it to you people. And let me pause the recording. One quadratic factor is downstairs. This is basically about simplifying the fraction first. So therefore, this is x over x squared plus 4, and this is x plus 1. So basically, first multiply, which is x squared plus x divided by x squared plus 4. So this is an improper algebraic fraction. So after long division, it will become proper. So let's have a look. Let me just do the long division over here. X squared plus x plus 0 divided by x squared plus 4. So x squared over x squared is 1. 1 into x squared is x squared. 1 into 4 is 4. Change the sign and add. That is negative. That is negative. This cancels out. So we are left with x minus 4. So this is 1 plus x minus 4 divided by x squared plus 4. That is the first thing. It's not over yet. Break it up further. 1 plus x over x squared plus 4 minus 4 over x squared plus. How many marks is this? This is for 6 marks. Yes, 1 or 2 marks just for simplification. This is basic integration. This integration after adjustment, it's of the form f prime x over fx if the numerator is derivative of denominator. And what about this last one? This last one over here, this is of the form 1 over x squared plus a squared dx. That integral will be tan inverse x over a plus c, and don't forget 1 over a. So 3 different kinds in one particular question, but first it's long division and then simplification. So now let's have a look. Let me just adjust the page. Where is it? Okay, over here. Now let's look at the working. The first working is this. That is the long division thing. Second working is break this up. You cannot break the denominator. You can break the numerator. This divide by this divide by this. Then 2 written on the inside, 1 over 2 written on the outside. This one just taking the 4 on the outside. Now remember this thing, x squared plus a squared, so a is 2. This one half ln x squared plus 4. This one becomes x, very simple. 4 as it is, half as it is, tan inverse x over 2. And then plug in the limit 6, plug in the limit 0. So when we plug in 6, 6 goes over here. Let me highlight this. 6 goes over here. 6 squared plus 4, that is 40, 6 over 2. And then 0 goes over here. 0 plus 4 is 4, and tan inverse of 0. So now over here, 6 as it is, half ln 40, tan inverse of 3. Leave it as it is. 0 as it is, ln 4 as it is, and tan inverse of 0 is 0. So this is also gone. So now I'm left with 4 terms. 1, 2, 3, 4. This is a constant. These two are related with tangent. This is tan inverse 3. Leave the answer as it is. Tan inverse 3, we are not evaluating it. Find the exact value. So that is how you get this answer. A very nice question. You want to take a screenshot? Take a screenshot. All good? Let's roll on. This one, another nice question. This question number 9. It says the diagram shows the curve y is equals to sine x cos 2x for x between 0 and pi, and a maximum point m, that's m over here, where x is equals to a, when x is equals to a. The shaded region between the curve and the x-axis is denoted by r. So shaded region is below the x-axis. Area below x-axis will come out to be negative. That's natural. Find the value of a correct to 2 decimal places. So sine x, cos 2x, u is sine x, u prime is cos 2x, v is cos 2x, v prime is negative 2 sine 2x. When you differentiate, before that, do not simplify. Once you have differentiated, then apply the double angle, then apply the double angle. So this is giving you a sine square. So I have chosen the sine square thing over here. And then I have taken cos x initially common out. We have done questions like this in class. And then this is 1 minus 6 sine square x. dy by dx equals to 0, cos x is equals to 0, x is pi by 2, x is 3 pi by 2. What is the range? Uh, First of all, this is between 0 and pi. So this is 0, this is pi, this is the mid value pi by 2. That means the maximum should be somewhere lesser than pi by 4. So 0 and 3 pi by 2, definitely that's rejected. But you have to show this working. Show this working, then reject. 1 minus 6 sine square x is equals to 0. Sine x is plus minus 1 over root 6. Basic angle is this much. That is the answer. And then what else? The second part. Find the exact area of the shaded region. Give your answer in a simplified form. Now, in order to find the area of the shaded region, I need this thing, I need this thing. That's where trigonometry comes in. So now sine x is equals to 0, x is 0, x is pi, x is 2 pi. Cos 2x is equals to 0, 2 cycles in 360, 1 cycle in 180. This is pi by 4, this is 3 pi by 4. So therefore, these two are of relevance to us because pi by 2, this is pi by 4, this is 3 pi by 4. And of course, the diagram is not drawn to scale, but at the same time, it's not misleading. So you can see there is symmetry over here. So now these are the limits. Replace cos 2x with 2 cos square x minus 1. Multiply it out. This is direct integration. This is substitution. Because u is cos x, du is negative sine x dx. This is trig substitution. Case 4. U is cos x, the power is 2. U is cos x, du is negative sine x dx. Therefore, sine x dx is negative du. So sine x dx is negative du, and I have done the working over here. This negative du. So let me write it in green color. This negative, this du, that is sine x dx. And then we have u as cos x. So this is u square. And then this becomes this. And after doing the integration, that is when I have substituted this. Plug in the limits all together. After the basic integration, after this limit, simplify, common, that's for you to decide how much working you want to do. Cos of pi by 4, root 2 over 2. Cos of 3 pi by 4, negative root 2 over 2. If you have to square it, that squaring is also done on the sidelines. And just look at the working. Just look at the enormous amount of basic arithmetic surds that they are doing. That is why in O levels from this year, May, June 2025, they have included surds as part of the syllabus. It took them a long time to realize, but now they have realized it. So that is how this particular thing is done. Just look at the working. Look at all the shading that I have done. And that is the final answer. Naturally, it's coming out to be negative because area below the x-axis is negative. Just give the answer with the positive value. Differential equation, we are not focusing on that at the moment. And let me focus on this thing. Another stationary point thing that is normal. Implicit, excuse me. This is differential, normal thing. Another one with this thing. And in all these things, you have seen how identities were used. So now let's focus on this one. It says the diagram shows the curve y is equals to x cos 2x. For x is greater than or equal to 0, find the equation of tangent to the curve at the point where x is pi by 2. Simple. U is x, u prime is 1, v is cos 2x, v prime is negative. Dy by dx, x is pi by 2, you plug it in, you get dy by dx is negative 1. That is gradient of tangent. Are they asking tangent? Yes. X is this, corresponding value of y is this. Just write it down, and it's a beautiful answer. Y is equals to negative x. Find the exact area of the shaded region bounded by the curve and the x-axis. X cos 2x, this is algebra, this is trig, this is integration by parts. Before that, get these two values. There are multiple values because the curve is going, but we need the first two values closest to the origin. X is equals to 0, cos 2x is equals to 0. Therefore, this is pi by 4 and this is 3 pi by 4. But we just need one of them as the origin. The other one is pi by 4. U is x, du is 1 dx. dv is cos 2x, v is half sine 2x. Integration by parts, x uv minus integral v du. uv minus integral v du. Basic integration. You can just take the half common out if you want to. Otherwise, no use of torturing yourself. Just plug in the values, simplify, and you get this answer, which is pretty basic. And I think I've gone through all the important questions of the year 2023. So that's about it from my side. Take care, everyone. Allah Hafiz.